Hello and welcome back to our second tutorial in Unity for virtual reality. This time we'll be going over chapter 3, which is working with inputs and interactions. As I mentioned earlier, virtual reality is more of a sophisticated medium technologically in terms of being able to give inputs to your game, since we have, say, motion controls. We're able to turn our heads, and as well as using the buttons on our remotes. But you can grab objects, you can teleport to different locations, you can walk around using what are called interactors that are included in the XR toolkit. Just a few examples include ray interactions, direct interaction, gaze interactions, locomotion, and teleportation. We'll also look at some examples using haptic feedback with our controllers, adding attach points to when we grab onto objects, and socket interactions as well. If you recall from last time, we went over just the bare bones basics on installing Unity, installing all the necessary packages, and simply being able to create a scene where we can have the headset attached and actually get a picture to display on our headsets from the game. We also were able to attach objects to our hands and see them move around. If I load up the scene and you see my gameplay window, I have two rays, one coming from each of my hands that are associated with these cube objects. So these rays will allow us to point at objects and be able to interact with them, or pointing on the floor and teleporting to a location of our choosing. Another topic of relevance is asking the question of why interactions matter so much. Well, as mentioned in chapter 1, being able to have an interaction which involves a action and reaction allow us to become more immersed in our experience. I believe our author made some examples such as walking and hearing your own footsteps, or for example, when there's a push, there's also a pull, or if you touch an object, you were to feel haptic feedback. Those are ways that we can allow our user to feel a more realistic experience, and the way that they interact with the world around them, this virtual world, is very important when it comes to the quality of their immersion. So what we're going to be doing is setting up a demo using some very basic objects and going over all the different types of interactions you can have with said objects. So we'll start with creating a completely new scene. Fortunately, we already have a scenes folder down here with our sample scene already included. And again, in order to add an object to our project folder or any of our folders, we can just right click, go to create, and we have scene down here. So we can name our new scene whatever we'd like. Rename because I already clicked off of it. We'll call it base demo. The book calls it 00 base demo, base underscore demo. Hit enter. Now you're gonna have a fresh new scene with just your camera and directional light, as we did at the very beginning. All right, so as we did with our first scene, we need to add the floor. So I'm gonna go to right click on my hierarchy, go to 3D object, and place a plane. Make sure that it's at the origin as per usual. Focus on it. All right, so here we have our floor. We're gonna make this its own. We're gonna make this have its own material. And for the sake of organization, I'm going to make a folder. So right click, create, and go to folder at the top here and call it materials, so that I can place all of my materials, old and new, in here. I want to give this a new color. Let's give it like a yellow. So go to create and go to material and call this maybe ground, since we already have floor named. And apply it by dragging it onto the plane. So here's our floor. What our goal is we're going to add a little table with a bunch of primitive shape objects to kind of showcase all the different interactions we can do with our XR toolkit. So what I'm going to do is I'm going to make a table. The thing with the table is I want this to be a child of the plane. So there's two ways I can add a child. I can just right click, create 3D object, cube, and then drag it under the plane such that it is now a child of the plane. You'll see that if I set it to the origin, as I mentioned in the last tutorial, if you have a child of a parent object, the child's transform is relative to that of the parent. So if the parent moves, then the child moves as well. Another thing I can do is I can just right click on plane and then choose create a game object. Choose to create a game object, and now it will automatically be a child of this plane. I'm going to rename this. Instead of plane, I'll call it the floor. And the cube is going to be the table base. I'll rename it table base. Well, it doesn't exactly look like a table base yet because it's in the floor. So I'm going to bring it up by 1/2 since it's centered at 0, 0, 0. So now it's completely above the floor. I'm going to give it a new material as well and call it table base. If you were to take a material and apply it to multiple objects, maybe you want to give it a more generalized name, but in this case, it's being applied to one object. I'm going to right click on floor again and create the tabletop, which will also be made out of a cube. But the tabletop is going to be more rectangular, so I'm going to give it this transform. It's going to have height 1 on the y-axis, and it will have scale 1.8, 0.2, and 1.6. So now you can see this is our tabletop where we'll be placing all of our primitive shape interactables. So I'll go to create material and call it tabletop. Now we're going to give it like a greener color. Drag it on. Okay, so now we have our table to mount all of our objects on. And again, if I were to move the floor, the table will conveniently move along with it without getting off-shifted from the floor. So next, we're going to add all of our objects, all of our interactables, and we're going to have all of them be children of a empty game object called VR objects. So I was able to right-click and create empty such that it doesn't have any kind of, say, 3D mesh. It doesn't. An object does not have to have a mesh, but every object has to have a transform. So we'll just set it to the origin. And now what I'm going to do is I'm going to add all of my objects. So I'm going to create 4 different basic shapes. A cube. We also have a cylinder, a capsule, and a sphere. Now I can select all of them and move them up a spot. And I want these to be a little bit smaller, so since I've highlighted all of them, I can just scale all of them at once to 1/4 of their size. And at this point, I'm just going to drag them into their respective locations. They don't have to be perfect, as long as they look like they are sitting on this table. Next, what I'm going to do is I'm going to create some materials for all of them. Okay, I want like 4 different materials, so I'll just duplicate these and rename them. Capsule. All right, so now we have our 4 primitive objects. Now that we've done this, I don't want to risk losing our progress if we make any kind of mistakes. In order to interact with these and even to move around in our world, we have to implement what's called a locomotion system. The locomotion system, again, allows us to move around with the joysticks, similar to how you move around with, say, a PlayStation controller. You use the left analog stick to control how you move around. So what I'm going to do is I'm going to go to my scenes folder and make a new scene. I'm going to save this and then duplicate with Control D to duplicate my scene so that this is essentially a backup. So if I lose my progress, I can start over. If you don't save the scene and then duplicate it, you'll just get an empty scene that we started with. So make sure that you save before duplicating. And I'm going to name this 01 locomotion _ setup. You zoom in. You can do Control and use the scroll wheel so you can see the entire name. Well, it still doesn't fit. But you can highlight it and see it down here in case you can't see the full name. So just as we did with our very first scene, we have to add our XR rig. So I can right click in the hierarchy, go to XR and click on XR origin. Bring it over to 0, 0, 0. It is. We also have our interaction manager, which the location of this isn't really important. Uses this XR interaction manager script. This is what's, as it implies, going to manage our interactions between all of our all the game objects we have in our scene. Also, we have a duplicate camera. Remember that this XR origin includes a main camera, so we can delete our old camera, get rid of that. The book mentions that your interaction manager must also have an input action manager, But in this version that we were using, the XR origin rig already has the input action manager as a component here. So next what we're going to do is we're going to add our locomotion system. We can go to hierarchy and right click, go to XR, and you can see that we have some of these interaction systems. We have Ray Interactor, Socket Interactor, which allows us to place objects into containers. But in this case, we're going to use the locomotion system action-based. So action-based implies that you're getting action from inputs on your controllers. As you can see, it's been added into our scene. When we click on it, it has a few components. So it's locomotion system script, a teleportation provider, which will allow us to teleport different places. Once we've set it up, we're going to need some kind of teleportation plane on the floor. And we also have a snap turn provider. The snap turn provider allows us to turn left and right with the analog sticks at fixed angle increments. You'll see how this works in the demonstration if you don't understand. Now, a lot of these scripts, if you're not familiar with how Unity uses scripts, contain public game objects or specific object types. This script needs an XR origin to function, and it says none at the moment. We need to take our XR origin from our hierarchy and drag it into this spot here. Also, if you see in our snap turn provider, we need left and right hand references to our controllers. These aren't going to be dragged in like the XR origin game object. These will actually be chosen from my input manager, which, if you remember, is in my XR folder. Oh, here we are. It's in my samples folder. We have this XRI input actions, and we have things that we have things like touchscreen, head track, right hand input actions. These are all of the inputs we could possibly get using this toolkit. And one of them is going to be used for the snap turning. So if I go back and go to my reference for my left hand, I want to choose XRI left hand locomotion. This one, the very last one, says turn input action reference. And I can do the same with the right hand by typing XRI right hand locomotion / turn. My only option. So to confirm that this works, I'm going to boot up the game with my headset and see what happens. So if I go ahead and click play, I'm going to load my scene. Hopefully you can see my point of view once it does. So I'm stuck in the table, but if I use my right or left analog sticks, I can actually turn myself now. I'm not able to move forward or backward exactly, but I can at least rotate myself. I'm also stuck under the table, so I'm gonna have to fix that as well. I myself am not much of a fan of the snap turning. It just feels too clunky or rigid. And later in this tutorial, we'll talk about using continuous turn providers, which allow us to smoothly rotate in the virtual world. So, but first, we want to go over teleportation. So I think somebody in one of the discussions mentioned motion sickness. You're actually more prone to getting motion sick in some of these games in which you are continuously moving around with an analog stick, because in the virtual world, you are smoothly moving throughout and maybe your body is not. And when you have that kind of discrepancy between your physical body and the virtual body moving around, what you see, that can cause motion sickness. So sometimes it's more convenient to the user to allow them to teleport around instead, so that they're not as prone to this. So we're going to set up teleportation, but before we do, let's duplicate our scene again so that we don't lose any of our progress. So I'm going to save this scene, Control S, and then Control D after clicking on locomotion setup, and rename this new scene as 02 underscore teleportation setup. Double click, we have our same scene again, and we're going to go to the teleportation provider that is under our locomotion system, and this will enable teleportation features for our XR rig right here. So in order to teleport anywhere on this floor, what we would like to do is be able to take those laser rays that we have, point on the ground, and click somewhere on the ground, allowing us to teleport there instantaneously. In order to do that, we need to click on this floor that we have, the actual floor plane, and give it a teleportation area component. So on the teleportation floor game object, I'm going to go to add component down here and type in teleportation area. Now that will allow this floor object to become an area for us to teleport on. First of all, we need our interaction manager, which we can just grab from here directly in our hierarchy and drag it in. We're not going to use any kind of custom reticle yet, but this component enables the VR rig to teleport to any part of this enabled area by using a raycast and trigger pressing the trigger button. Again, that raycast is that red laser that you saw while in play mode, and the trigger press is an event that occurs when you press the trigger button. Now, in the teleportation area component, we want to designate a specific layer called floor in the interaction mask right here. This will dictate what types of objects you can interact with. So if you've done some Unity projects before and you look in your project settings under edit and you go to physics, you have all of these layers, layer collision matrix. Maybe you don't want certain objects colliding or interacting with others. You can put them on separate layers and ensure that they don't collide with each other, for example. So this will prevent us from being able to, say, interact with any kind of object on that layer and only specific objects in a layer. So what I'm going to do is we want to make a layer called floor. So I'll add a layer, go to interaction layers, and for some reason the book chooses user layer 8. I'm not sure why that is, but we'll just leave it as that for now. Go to user layer 8 and call it floor. Now, when I decide to choose its layer interaction layer mask, floor will be an option. So I don't want everything. Let's start with nothing and then click floor. So now it's only going to be part of the floor layer, or interacting with the floor layer. Oh, also notice that in our teleportation provider, this is empty. We're going to need to drag our locomotion system game object in there. So now that is all set up, we're going to go ahead and test it again. I was getting some errors and the controllers were not responding. Don't forget that when you install your XR rig, you need to add your presets to your left and right controller for your inputs. You add your left XRI default preset and your right hand controller XRI default input presets. I have my arrows, and you can see that when I point on the ground, they turn white, and when I click, it allows me to teleport where I'm pointing. But for some reason, I'm getting these little curves towards the origin of my plane, even though that's not actually where I'm pointing and it's not actually where I end up. So that may be a bug that we have to fix. I believe it has something to do with the ray casting, because that's what the actual lasers are coming from. Okay, so in order to fix the issue with the bending lines, what you need to do is you need to go down to each of the controller settings. Let me turn off my camera so you can see this. You have to go to the left and right controller and turn the line bend ratio to 1, which is down under XR Interactor Line Visual, which actually gives you the graphics. So if I had it at default at 0.5 and I point my line at the plane, I turn here and use the middle finger button, it points towards the center of the plane as shown in the last time I hit play mode. But if I change this line bend ratio to 1, now it won't do that anymore. So it'll go straight line and teleport at where I point. But make sure that you don't do this change during play mode. If you do this change during play mode, it won't save. Any changes that are made during play mode will not actually be implemented. So I need to turn off play mode and then go to line bend ratio and turn them both to 1. Now it allows me to teleport with middle finger to wherever on the plane I point. Now let's say that we don't want to be able to teleport anywhere on the floor, because in this situation theoretically we could teleport into the table, and let's say that we don't really want our player doing that. We can actually set up a teleportation area that is a specific area on the map that you can teleport to, which can be useful when you're using fluid locomotion, like moving around with the joystick instead of just teleporting everywhere. Let's make a duplicate scene. Oh, before that, make sure to save your current scene, Control S, then click the scene, Control D. And we're going to rename this one 303 underscore teleportation underscore areas, as in plural. Click. So now what we're going to do is we're going to create an empty game object that will serve as the parent for all of our teleportation areas. Create empty, name it teleportation areas. Make sure that we have all the transformers at 0, 0, 0. And we're going to place this slightly above the floor plane. So let's give it a Y of like 0. I don't know, 0, 1. Something that's barely above 0. And we're going to add a plane called Area 1. Create empty. Well, not empty. Create 3D. After right-clicking on teleportation areas. Select plane so that it's a child. And we're going to reduce its scale to 0.15. Before that, we'll call it Area 1. So we're going to make it scale 0.15. 0.15. Well, the Y doesn't really matter as much because it's a plane. We're going to give it a new material as well. So let's go into our materials folder, right click, create a new material, and we're going to make it purple. Let's call it like EP area for teleport area. So just as we did with the first area, we're going to add a component, the teleportation area component to this. So click on area 1, that's a child of teleportation area. Click add a component, give it teleportation area component. And we're going to change the interaction layer mask to the floor as well. So this is also a teleportable floor object. Remember that you need to have the interaction manager, which is up here in your hierarchy. Drag it in. We also need the teleportation provider, which will be the locomotion system. And now we have both this purple area and our yellow floor as teleportation areas. So we're going to need to get rid of the floor's teleportation area. You can delete it or just deactivate it and click on it. Also, we're going to set its interaction layer mask to nothing so that we don't accidentally click on the floor anywhere and teleport there. And now what we're going to do is we're going to take area 1 and just duplicate it 3 times. Control D, Control D. Let's name these areas 2, 3, and 4. And then we can kind of disperse them to all 4 corners of our plane. That means this will be, I guess what we could do is we could select all of them, give it transform of 3.5, 3.5, and then just change the signs to plus and minus. For area 2, minus 3.5 in the X, positive 0.5 in the Z. This one double negative, make area 4 in the Z. Okay, now we got our 4 locations that we can teleport to. So let's go ahead, save our scene, and test it out. Okay, so now that I'm here, again, I can still rotate using left and right triggers, but now my rays only turn white when I'm pointing at one of our teleportation locations, which I'm automatically taken to wherever on it I'm choosing. It doesn't have to be at the center. It can be at the very corner as well. That's nifty. We're only able to teleport to specific locations on the map now. As I mentioned earlier, I'm not the biggest fan of the snap turning, so we're going to make another scene where we implement what is called continuous turning with a continuous turn provider. So I'm going to save the scene, duplicate it again. Now our next scene is going to be named 04 snap and smooth turning, so that we'll get to directly compare and contrast the differences between both of them. I'm going to go to the locomotion system because that's where I have the snap turn provider enabled currently. So what we could do is we could choose to enable it on just one controller. Let's choose to have the right hand be responsible for snap turning. So we'll disable the left snap turn action. Now what we're going to do is we're going to add a component called a continuous turn provider. The continuous move provider, continuous turn provider. We're going to click the action based. You can see that we could actually set the turn amount to only 45 degrees each time. This is the turn speed. This debounce time is the amount of time the system will wait before using another snap turn, so it's not too quick. Anyways, we're gonna, since we set our snap turn to the right hand, we'll set our continuous turn to the left hand by clicking this box. And we're going to choose XRI left hand turn. Action based one. This is the input action reference. This one says snap turn. This one just says turns. We're going to simply says turn without snap turn. All right. Now if I use the left stick, I can continuously turn so that the turning is more fluid as compared to when I use the right joystick. It is more incremental at 45 degrees. Next, instead of teleporting, let's say that I want to be able to use locomotion, which is using the left stick to move around. Most VR games use the left stick for locomotion and the right stick for turning. I mentioned we want to use left hand for the locomotion, so I'm going to turn off the left hand and only allow us to turn continuously with the right hand. I'm going to use right hand turn. Choose this turn, not the snap turn. Also, we can adjust our turn speed, but I think 60 is fine. We're going to save that scene, duplicate, and rename this to 05 continuous locomotion underscore locomotion. Now I go to this scene. We're going to find the locomotion system in the hierarchy and go to its move-based provider. I guess I could put the origin. Not a big deal. Just so that the camera doesn't pan way out of... See, I don't have anything for continuous movement, so I need to go to add component. And I have a continuous move provider, action-based. Add that as a component. I need a locomotion system, which can refer back to itself by dragging it in here. Click my continuous turn, did not have that either. There we go. And kind of following a similar process as earlier, I'm going to turn on my reference for the left hand, and this time I'm going to choose XRI left hand move. So I've grab move. I'm going to choose the regular move. Double click, and now when I hit play again, I should be able to continuously move with my left joystick instead of being restricted to teleportation. Now, when I use my left hand, I can move forward and backward, I can strafe left and right, and I can also simultaneously use my right hand to turn. Now I have a bit of fluid motion. Again, as I've mentioned before, this can cause motion sickness to those who are not familiar with using virtual reality because, again, their virtual body is moving. Their physical body is not. So if you're catering towards a more casual audience who may have not played much VR or used it often, probably want to let them just teleportate. All right, the next thing we're going to do is we're going to implement interactor components to allow us to interact with our interactables. Now, object interactions refer to the ability to grab and manipulate virtual objects, as I mentioned earlier, as if they were real-life objects. So to enable it, we're going to need to use interactor components. So again, in this section, I've mentioned there's ray interactors, direct interactors, which include grabbing, gaze interactors, which include looking at, and socket interactions if you want to put an object into a container. And the ray interactors allow us to just point at them using those virtual rays that we have from the controller, the little lasers. And each of these interactor components will have a unique set of capabilities and uses. So hopefully by the end of this tutorial, you'll understand how all of these interactors work and how they can be used and all the different possibilities for you to interact with objects. So we're going to make first a demo for the ray interactor. So I'm going to save my scene, duplicate it, and as you would assume, I'm going to rename this 06 underscore ray interactions. Open the scene. Now in our hierarchy, we'll have the hand controller game objects. If you open XR Origin and look at our right and left controller, we already have our ray interactors and our line visuals set up. So if you remember during our simulations, the rays are red by default, and when we're highlighting something, they will turn white. You can change the color of the ray cast to improve its visibility. So you can actually modify the line visual down here. In this case, just to make things easier, we're going to set the valid color gradient to green. So I can highlight both of these, and it brings up a gradient editor if I want to make it a gradient. But for now, I'm just going to make it a completely solid color of green. Make it like a darker green. Just so it... Actually, we can keep it like a brighter green. Close. We don't want a gradient, so let's delete these little arrows. So now it's just one solid color. So again, the valid color, it'll turn green when we can interact, and it turns red when we are unable to interact. Now what we're going to do is we're going to add object interactions. So let's go to our first object under our VR objects, the cube. So let's start with the cube. It has all of its default components, like the mesh renderer. It even has a collider that it'll collide with the table so that it doesn't just pass through it. We need to give it an interactable. So let's allow ourselves to be able to grab this cube. So I go to add component and I type in XR grab interactable. I can add that as a component. Again, like every other interactable, I need to give it the interaction manager here. And I want to give it its own interaction mask. I'm going to add a layer and go to layer 9. I'm going to call it object. I go back to my cube, and I can give it that interaction layer mask of object. Oh, it's mixed again because I need to make sure I click nothing first so that it clears everything and then click object. Okay, now that it has this XR grab interactable, I'm going to click save, and I'm going to hit play. And I can actually just walk up to the table. If I point at the cube, it highlights it. And now I can pick it up if I press the middle finger button. Now I can actually hold the cube. I can throw it as well. It has its own gravity. It has its own physics and colliders as well. So I can kind of play catch with it. Because this is, I have ray interactors, I don't have to be right next to it to grab it. I can actually point at it from a long distance. Say I teleport to the other side of the map, and then I point at it, I can grab it from all the way over there, which may not be as realistic. And if I press up or down on the right analog stick, it actually lets me control the distance. Yeah, so when I added this XR grab interactable, it actually gave the cube a rigid body, which these other components or other game objects do not have that component. When I add the grab interactable, it gives it a rigid body. The rigid body is the component in Unity that allows an object to have physics or exhibit physics. So it has a mass, it uses gravity, it's able to collide with objects, etc. So all of these cubes are given a collider that allows the cube to collide with the table. The reason that the cube went through all these other objects is probably because when I was holding it, it actually just would follow my my laser regardless of whether it collided with a hidden object or not. But these are not going to, at the end of the day, these objects will not be moving unless they are given a rigid body. Now we're going to discuss anchor controls, which are used to improve object interactions with the ray interactor. So we're going to fine tune the position and the orientation of virtual objects to make it more precise. In other words, if you're holding it in your hand, we want to make it so that it actually looks like it's positioned properly in your hand. You can use the joystick of your hand to extend or retract the object and rotate it, like in that example I just did, which is not as realistic, obviously. But this can be useful in puzzle games and problem-solving games if you need to reach further away, or just more capabilities for the player. So if I go back to my ray interactor on my hands, these all have anchor control enabled. This allows the user to move the attachment point. Also, these don't have the interaction manager attached, so go ahead and add that. Not that it actually impacted our play, but it was probably included by default. I believe that if there's nothing attached automatically, the script looks for the interaction manager and attaches it manually. If I go into play mode, I can change some of these settings and see how it affects my interactions. I have the object, again, I can use the analog stick to rotate and turn as if I'm kind of levitating the object. Now, if I go to, what am I using, the right hand? I turn off anchor control. That's disabled now. Next up are direct interactors. That's the second interactor component that we're going to talk about. So unlike the ray interactor, you actually have to come into physical contact with the object before interacting with it. So that means that you can't just grab it from a distance, like far away, like you're using a lasso or that laser. So this can be more realistic because obviously in real life we can't just levitate and grab objects that are far away from us like that. So you actually have to interact more naturally with the objects, making it more realistic. Also, it looks like I forgot to make a new scene at one point, so I'm going to call this number 8, 08 underscore direct interactable. I'm not sure what scene 7 was for. It says object interactable scene. And what I'm going to do is I'm going to add a direct interactor to the left hand. So that, I'm adding one type of functionality to one hand and another type of functionality to the other hand, kind of like the snap and continuous turn, so we can directly compare the two features without having to make completely separate scenes for them. So on my left controller, I'm going to give it a XR direct interactor, so XR direct interactor component. So why couldn't I add that? So it turns out I couldn't add it immediately because I already have an XR ray interactor. I can only have one type of interactor for each hand. So what I'm going to need to do is I'm going to need to remove this. Or remove its ray interactor and give it a direct interactor instead. So the right hand will interact using rays and the left hand will interact directly. I can give it its interaction manager, the XR interaction manager. The attached transform will determine where on my hand the objects grab, which is kind of hard to determine if I don't have a 3D model hand for my controller yet. Give it a layer interaction mask of object, because it should only be able to interact with all the objects on the object layer. Next, we have to add a proxy. So that tells us, that's basically the radius around our hand at which the game says, okay, you're close enough to grab it now. What I can do is I can actually add a sphere object as a child. So what I'm going to do is right click the left controller, add a 3D object, sphere, and I'm going to attach it to my left hand, which it looks like it already is. Well, let's see what happens. As long as the position is set to 0, 0, 0, it should be correct. So what I'm going to do is I'm going to name this hand sphere. Let's call it. Actually, I'm going to call it left hand. And so this is already given its own collider. I'm going to use is trigger. So this trigger will allow the game to detect whether I'm close enough to grab objects. Obviously, this is way too big. I'm going to set the scale to, let's do 0.45. And the book is asking us to set it to 0.15 in the Z position. Probably to bring it a bit closer to our bodies. Now, we're going to give it a new material called hand. Create a new material. It looks like tabletop 1 is already a duplicate, so let's name this hand. What we can do is we can make it like a transparent color so we can actually see through it. Like a light blue. In order to make it transparent, you just need to lower this alpha value. You'll see that when I apply it to the hand object, it's not letting me do right now because the camera's in the way. Doesn't look very transparent. Let's try it again. So we gotta lower the alpha a bit. Okay, so I can actually make it look transparent if I change the rendering mode to transparent and then change its alpha like that. So what we're gonna do is copy the sphere collider and give it to the left controller object. So add component, give it a sphere collider down here. You can just paste component values so that it's the same as the sphere. Unfortunately, it looks like it didn't use the same size. We have to resize it to fit the hand sphere. I suppose this was just to allow us to get the same size, but I'm not quite sure what the point of this was. I guess they just wanted the collider on... They wanted the collider to be on the controller, but also having a visual reference for the right hand. This is like a little bit lower, so let's be on the sphere like that, and then we're gonna get rid of the collider from the actual sphere. So now this collider is on the left hand component. So now we should be able to test our interactions, and if you walk up to the cube game object, we can press the left hand control trigger when the hand sphere is touching it. Okay, so I have my controllers connected. This represents my hand now, which happened. When I get close enough to the cube, I can actually pick it up now. Looks like it attached to a weird point on facing towards. That might be some by default. So I can pick it up with the laser on this hand, or I can grab it directly. Now, if you noticed, it kind of attached to a weird spot on my hand. If I wanted to be in the front, what I can do is I can just create an empty game object so that it has a transform. We could call it attach point. And I can use that object's transform for my attach transform. Right now, it should be at 0, 0, 0. And I can actually adjust it in game while playing to see where it should attach. If you're holding, let's say, an object in your fist, but it's not exactly lying in your fist, it's a bit overlapping through your fingers, you can adjust where this attachment point will be. So I have this, my hand now, it's transparent. Again, when I grab it, it's facing towards me, which seems kind of weird. I kind of want it facing the other way. So what I can do is I can hold the object in my hand while manually changing this transform. So if I go to my attach point transform and adjust the Z, you can see that it moves in my hand while I'm still holding it. So if I want it to be in front of me, I can change the Z to be a bit positive. Or now it actually looks like I'm holding it in front of me from where I grab it. So when I grab the object, now it looks in front of my hand. All right, so again, the direct interaction allows us to exhibit something more similar to real life, where you have to actually go up to an object and pick it up right in front of it. So, and again, when you have both types in each hand, it allows us to have a more versatile and engaging experience. Next, we're going to talk about gaze interactors, which is actually not a default part of the toolkit. The gaze interactor comprises of a third-party component developed by Tomas, I don't know how you pronounce that, Sareva, and it was made available to the community on his GitHub. So this was more common in early development when they were smartphone based. So when you had a smartphone, you didn't have controllers to pick up objects. So you would have to look at an object for, say, a certain amount of time before you can interact with it. What we're going to do is we're going to go to his GitHub at github.com/Tomas Sarevia Unity Gaze Interaction, which is, this link is in your textbook. All right, here is his GitHub. So it's github.com/Tomas Sareva Unity Gaze Interaction here. I'm going to click on releases in the bottom right corner of the screen to go to the download screen. So we go to releases right here. And I want to download the package, so I could just click on Unity or Gaze Interaction Unity package. And fortunately, Unity allows us to install packages just by opening the link while having Unity open. So while I have this scene open, if I double click it in my downloads folder, let's have it open in the version that I have currently running. Now, this little window is going to pop up asking me, hey, which assets from this package do you want us to import? Let's just do all of them. Click import. Now, it should show up in our assets folder once the package has been installed. So go to assets, and now I have this gaze interaction folder available to me. So we're going to make another scene for this. Save our current scene, duplicate, rename, 09 underscore gaze interactables. And we're going to go to the gaze interaction folder that we've just installed and look for gaze interactable and gaze interactor. These are both PDFs. I assume this is like a README. We have to go to the prefabs folder. Here they are. So we're going to follow the same concept as our other interactors, our ray interactor and our direct interactor. And we're going to focus on setting up the gaze reticle first. A reticle, if you're not familiar with, say, I don't know, first-person shooter games, that's the little icon that indicates the direction that you're aiming at. And so this reticle is used to indicate whether the object we're looking at is interactable or not. So here's how we're going to set up our reticle. So we're going to go to the main camera game object that we have attached to our XR origin. And now we are going to add a gaze interactor prefab. So prefab is short for prefabricated object. So this is an object that we can kind of just copy and paste into our scene as a template. So I have the gaze interactable and gaze interactor. I'm using the gaze interactor, and I'm going to add that as a child of my main camera by dragging it on here. So it has a gaze interactor script. And so this is the prefab that just got added. I'm going to make a new layer because I've had the teleportation floor and the interactable objects. I'm going to make a new layer and call it gaze interaction. But this layer specifically, I'm going to add on the top right corner. This is not an interaction layer. This is just a completely separate layer. I'm going to add a new layer. Maybe I call it user layer 5 or 6. Right, yeah, I'm going to call it user to get layer 6, and I'm going to call it gaze interaction. And now my gaze interactor object, I'm going to click layer and have it be gaze interaction. Now I'm going to set the minimum distance to 0, which it already is. I'm going to set the maximum detection distance to 6, because if I had it at 0, it would be right in front of the thing for it to allow us to activate. Time to activate, 6 seconds. I assume we have to stare at whatever we're going to interact with for 6 seconds for it to highlight, which sounds like a while. I think I'm going to leave it as 3. So the minimum detection distance and the maximum detection distance is measured in meters. So again, that's how far or how close it will work on these objects. And then, yeah, the time is, as the book says, how long you have to look at it. We also have to change this layer mask to gaze interaction. Next, we're going to add the gaze reticle prefab to this to the gaze interaction prefab folder. So if I go to gaze interaction and go to resources and prefabs, I'm going to have a gaze reticle here, and I can add that to my interactor. So this gaze reticle is kind of like I said, a little image that tells us where we're looking at, and it has a canvas. This canvas is what we're going to display our image on. Now we're going to set up gaze events. So previously we used the cube game object for ray and direct interactions. Now let's choose a different object. We're going to use the little yellow capsule over here for gaze interaction. First we use the gaze interactor prefab, and this time we're going to use the gaze interactable prefab on the cylinder object. So we're going to take this and make it a child of the capsule by dragging it on. Gaze interactable. So we're going to make sure that it's on the layer gaze interaction, such that images that are on the gaze interaction layer can interact with each other. We have the one on the camera, and then we have the one that is the capsule. So only those will be able to interact with each other. We're going to enable the is activatable. We're going to click the is activable checkbox, and the box collider should be placed around the capsule. So we have to align the transform so it actually fits here. Let's take our box collider and lower it a bit. So let's go down along the Y. It looks like it's centered pretty well along the vertical axis. We need to make it a bit larger, approximately like this. These are both 0.9, and this is about, let's make it 2. So why not? And then just make sure that your layer again is set gaze interaction for the prefab, not for the capsule. So I have my little hand over here, all this stuff. When I look at the capsule, you can see there's a reticle that is loading. So this circle takes, how long did I set it? 3 seconds. What we saw is blue dot appears when you're looking at it, and it goes away when we look away from it. Those are categorized into events, as you can see under the gaze interactable component script. You have on gaze enter, on gaze stay, on gaze exit, activated, and toggle. So on gaze enter is when you first look at the object. On gaze stay is when you continue to look at it after the first frame. Exit is when you look away. Activated is when you've looked at it for that countdown time that we've set to 3 seconds on the interactor here. So we can dictate what ends up happening in each of these events. So what we can do is we can make the object change color to indicate that each of these are happening. So we're going to press plus on each of these events. Let's start with just these first 4. And we're going to select the function. This determines what happens. These are going to happen to the capsule. We need to drag the capsule object into all of these. Because we're changing the material of the capsule. We're not changing the gaze interactable. That doesn't have a mesh, so we can't about that. Now we're going to choose mesh renderer and change go to material. I don't know why it's named double material, but it is. So go to mesh render material. So what this is saying, it's going to change the material. We can change, for example, certain data types like the string, the name, send a message. We can make it move when we look at it. Things like that. Let's go to our materials folder here. We'll make it change colors. So I'll drag this in on enter. Maybe say it becomes black on gaze stay. We'll have it become purple on gaze exit, and then gaze activated. We will have it turn like a new material. Do like that. All right. Now I want to hit play again. So I'm gonna come over here, look at the object. See, it changes objects, or sorry, it changes materials. It looks like it turns pink only the frame that it's activated. So that just happens for a very split second, but as long as I'm looking at the object. In that case, perhaps we want to make the on exit material the default material so that it goes back to normal. Okay, now that we've gone over all these different types of interactors, so we've gone over ray interactor, direct interactor, we went over the gaze interactor. What if you want to enable multiple object interactions on a single object? You can add a multiple interactor component to the object. So if you want like a ray and a direct, or a gaze interactor and any combination of that, you can add one component to allow multiple. To do this, let's go ahead and make a new scene for this. Save our current scene, Control D, rename it as 10 multiple object interactables. Okay, I'm gonna open this. We're gonna add multiple interactions to a single object. We're going to do the following. We're gonna rename each of these objects as follows. We're gonna take the cube and we're gonna rename it cube-grab so that we know that this was the grabbable object. For the sphere, which I don't think we've added any kind of interactions yet, we're gonna name it sphere multi. Sphere-multi, because this is the one that's gonna be getting multiple interactions. So with the we're gonna call the cylinder. Oh yeah, as for the cylinder, we're gonna rename this as cylinder-multi. And with the sphere and the cylinder both selected, make sure you use Control-click so that we can select both of them, not Shift-click. We are going to both give it the components. So we're going to add 2 components. We're going to add both the gaze interactable here, and we're going to add the XR grab interactable. So now these should both be interactable via grabbing and gazing. For the gaze interactable events, down here, we're going to repeat the same steps that we did for the capsule by changing the material colors. What I'll do is I'll click on sphere, I'll add on gaze enter, on gaze stay, exit, and activated. Interestingly enough, we actually had the interactable be a component rather than a child object like with the capsule. But it still applies that we're going to have to give it that parent object. Oh, also don't forget to change the function to mesh renderer material. Almost forgot to do that because that's where we're going to add our material. All right, so I'm going to add the materials here on exit. Gaze enter, let's just make it light blue, and then on activate. Accidentally made this the materials. The parent object is supposed to go here. So by default, it's blue. Let's make that the exit color. We can have it orange on enter. We can set exit delay to 0.3. Oh, don't forget to click is activable for both of these. And once you set is activable to checked, make sure to put them both on the gaze interaction layer as well. Now, both of these objects, well, I guess 3 of them, the cylinder and the sphere, both follow the gaze interaction. But I can also pick up the sphere as well and also interact while looking at it. So the sphere actually exhibits both of those interactions. And notice that the reticle actually exists on the planes of the collider. Because remember, we gave this capsule a box collider, so it actually comes out to the corner over here. Next, what we're going to do is enable haptic feedback, known as haptics, which if you aren't familiar with what that means, haptic means vibration, so you're feeling touch, essentially. So it communicates information or a sense of touch in VR. So it can be used to simulate the feeling of holding or touching objects for an extra layer of realism. So what we could do is maybe when you pick up an object, your controller may start to vibrate or give the sensation that you're grasping something by incorporating haptic feedback. So that allows us to create more immersion through touch. What we're going to do is we're going to make a new scene again. Go to scenes, save this one, Control D, rename it as 11 underscore haptic feedback. All we have to do is go to the XR direct interactor, or the one that is responsible for directly touching things, and click enable haptics. So down here, we have haptic events. And this actually allows us to select in which case we will feel that. So we could do on select entered, which is when we first touch the object. You can change how strong the haptic is. And maybe we have it last for 0.2 seconds. On hover entered. This can help if maybe your player is in some kind of escape room or a puzzle game and they're trying to search for a hidden object. Maybe you can use haptics or like haptic intensity to know that they're close to an object that they need to interact with as kind of a hint. So all of these events are similar to the gaze interactor. You have on selected, on exited, on canceled, etc. that you can tailor towards whatever your application is. So the book next discusses attachment points, which I should have already set up in a previous, it's already set up in a previous example. I must have forgotten to save the changes because they are supposed to exist in, or I must have made the changes in play mode, so they weren't saved. But remember that you add that to your direct interactor as well. You have an attachment point transform that is this separate object that's also a child of the left-hand controller. The very last demo for this chapter is adding socket interactors. So those are the interactors that let you place an object in a holder or container with precision and feedback. So this can be done using a socket or a designated location where the object can be placed. So we're gonna make a new scene. We're gonna make one last scene. Since we skipped the scene for the attach point, we call it 13 underscore socket interactors. So I'm gonna create a new empty object, game object. So right click in my hierarchy, go to create empty, and let's call it sockets. We're gonna place it at the same level as the tabletop by using our transform. So we'll set it to 0, 0, 0. And our tabletop was a little bit higher than 1. So let's drag it and see what happens. It's like 1.2. So we've placed it up here, and within this game object called sockets, we're gonna add a child and give it another empty object, create empty, and we'll call it socket 1. We're gonna add a sphere collider to this component so that it'll know we are within the vicinity of this socket. So collider is capsule collider, circle collider, sphere collider down here. And we're gonna resize the sphere so that it sits on the same level as the table. So now we're gonna give this socket 1 object, a socket interactor. So type in socket, XR socket interactor. We have the attach transform. So we'll need to give it an attachment point. Interaction manager. I don't think you have to drag this in, but it's just good practice. Let's give it an attachment transform. So what I'll do is we'll add another game object to this and call it attach point. It's attach point. And it'll just be its origin. And we'll drag this attachment point transform into the attach transform. Now, as a child of this socket as well, we're going to give it an actual 3D mesh for it to hold the object. We'll make a plane, and we're going to call this socket indicator. Why? Because we'll make it glow different colors to indicate, hey, you're able to place this here. We're going to tone down the scale to 0.2 so it'll fit on our table. Sorry, 0.02. That's a bit big still. Let's make it 0.02. Drag it out to the front. Maybe let's actually move the socket forward. Have this be at 0, 0, 0 so they all line up. There. Here we go. But we do want its collider a bit higher. All right, so now our socket is set up at this location. Now, before we test it, we have to make sure that the objects will have their collision detection set to continuous dynamic. We need to set its layer mask to object such that it only serves as a socket for the objects we have on the table, because these are all set to type object. So remember, the cube had a rigid body, and we want to make sure that their collision detection is set to continuous dynamic. And it looks like these other objects don't have rigid bodies yet, so this one actually does, continuous dynamic. This one does not, so let's give it a rigid body component. Again, that allows it to use physics. Does the cylinder have it? It does, collision detection, dynamic. And then we can make three more actually, sockets, and disperse them across the table. I don't really mind the name. Okay, let's go ahead and test it. Pick up the cube. So the reason that our sphere was that our cube was bouncing off of these is because we set all of these colliders to, well, we didn't set them to trigger. So it's just going to bounce off of these rather than serve as a trigger. Let's go ahead and try simulate. So if I grab the object now, I have these little highlights saying, oh, I can put the cube here, and it fits into these little slots, which it looks like I probably didn't set their transform properly because so for all these sockets, we're going to need to change their attach point transforms to be a little bit higher. I drag these up a little bit. Okay, so in order to place these, you need to make sure that their layer interaction mask is object as well for the sphere. Yeah, let's try one more time. So it's the transform for the attachment point's a little bit off. You can move it up or down to adjust it. Now that I have these. So it's pretty cool that it gives a little preview of where the object will snap to. Lastly, Unity provides standard tools for not just VR development, but also experimental packages and features. As mentioned in Chapter 2, in the installing section, you can download those from repositories in the package manager, which is found in Windows Package Manager. So if you press the plus icon on the top left, you can add a package by name and go back to our toolkit, which you would type in com.unity.xr.interaction.toolkit, which is already here for us. And if you go to samples, for example, you can add these different imports for MetaGaze adapter, device simulator, all these extra packages that you can experiment with. So I don't know about how you feel. That was definitely a lot of material to go over, but we went over all the different types of interactors, including, again, ray interactor, gaze interactor, direct interactor, and how we can set up different events to happen. Those different responses like grabbing the object, teleporting, haptic feedback, things like that. So remember that in order to exhibit more immersion for your user, it's key to add a mix of features to also cater to your different types of users, whether they're more prone to motion sickness, like I mentioned earlier, they're more casual versus more experienced. So in the next chapter, we're going to talk about more about game objects, prefabs, and assets to enhance the VR experience further. We'll also be going over making different types of materials to make your experience more colorful, vibrant, and realistic as well. So I hope you got a lot of knowledge out of this, and I'll see you in the next video.